We've already given away the whale. By the way, there is actually a Docker whale. Its name is Moby. Just in case you didn't know what room you're in, this is Ride the Whale Docker for Drupalists. Are there any note takers in the room? Anyone? Kind of, sort of? Okay. This entire presentation is already online at this link, and you'll get that link at the end of this presentation, so you don't need to write it down. First of all, you might be wondering, who is this weird person in front of you, and why the heck did they bring an inflatable whale to DrupalCorn? I'm Tess Flynn, otherwise known as Socket Wench. That's Wench, not Wrench. I am the module maintainer for Flag, Flag Friend, and for examples, and I love Docker. So first of all, what is wrong with MAMP? Who in this room uses MAMP as their local development environment? Raise your hands. Oh, there gotta be more than one. Who uses Vagrant or VirtualBox? Okay, that's a lot more. Okay, I'm going to tell you that I hated all of those solutions. I have hated them for years now. I used to really like Vagrant and VirtualBox, and about a year and a half ago, I actually started getting into Docker, and I have not looked back since. And there was a lot of problems that I actually had with the way that a lot of people do Drupal in local development environments. And it came down to a few different problems. Problem number one, there's no sandbox. So how many of you have been, working along, it's like, okay, I just finished up this project, I gotta go clean out my system, make sure and archive all of this project data so I can get my disk space back, and they're going, what the heck is this? How old is this thing? How long has it been in my system? This client is like from 5 years ago. It's been eating 5 gigabytes of my disk ever since, and I had no idea. The problem with a lot of these solutions that we've already tried is that whatever stays inside of your repository is like the inverse of the Vegas rule. It lives on your system forever. And the reason why is because it's like pulling weeds. There are files, there are databases, there are configurations, there are binaries, and it takes time and discipline to find them and remove them. And programmers are lazy. We're very good at mechanized laziness. That is what we do for a living. That is our good attribute. And the thing is, cleaning stuff up makes us not lazy. It's work, it's boring, we don't want to do it. Fortunately, Docker sandboxes everything. There are standard commands for delete, no matter what project or technical stack that you are using. If you're using Apache, Nginx, Node.js, it doesn't matter. One command deletes them all. Problem number two, your dev environment isn't repeatable. Okay, so you were cleaning out your system and everything's fine, and then you go, you know what, this system's just too old. There's too much junk in it. I'm just gonna go to my boss and ask for a new system. And your boss says, sure, here's a shiny new laptop for you. Yay, everyone loves new laptop time. And then you have to create all of your sites, all of your projects, of your clients all over again. And how did I do that the first time? You might have some instructions, but instructions generally aren't enough because human beings are fallible, forgettable, and often they're fried. They're under time constraints, or they're stressed, or they're exhausted, or they have other issues outside of the office that make it difficult to recall and rebuild environments. You don't want to depend on that. With Docker, there are no special snowflakes. Docker containers are repeatable by design. All of your configurations are in a few simple text files that can live inside of your repository. Problem number three, your dev environment isn't shareable. So you've been working on a client for a long time, and you get a new project member who's going to join your team. And they said, okay, take the next day and a half to go and set up your system. And about sometime after lunch, about 3:43 in the afternoon, you're just polishing off that second coffee, and they come to you and they say, I'm having trouble setting up the site. And then you say to them, oh, well, that problem, yeah, sure. All you have to just do is blah, 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 SQL, blah, 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 Drupal, blah, 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 Solar, blah, 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 MySQL. And the other developers come, oh, God, why are you doing this to me? I can't remember all of this stuff. You can't share a house of cards. That is what we build on local development environments in Vagrant, in MAMP. These are houses of cards, and you can't share them. They fall apart. Also, it adds hidden costs, including onboarding. There's also troubleshooting and recovery time. Your system crashes, and now you have to spend time rebuilding your environment. Or worse, you have that one project member, Earl, who only has this one problem, only on his laptop, and it's only repeatable on that laptop, and nobody else has the same problem. And that's because you find out 6 months later they installed this version of firewall, not this version. And it's like, what the heck? Why did that have anything to do with anything? But that happens. And it's eaten your time trying to figure out why. Have you ever heard of the dry principle? Do not repeat yourself. Do not repeat yourself. Let me say that again. Do not repeat yourself. It not only applies to programming, it should apply to servers too. You shouldn't repeat yourself. You should let the servers repeat for you. That's what they're good at. Docker is shareable by design. You download containers from the internet and you can add the build files to your repository. It's a few text files, it's very light. You don't have to have a 15 gigabyte shared directory somewhere where everybody copies down the same Vagrant install every bloody time. Okay, now that I've got really riled up, let's talk about how to get Docker. Do I need to pay for it? I'm a cheapskate. So I don't like paying for things. Fortunately, Docker is free and open source. You can go to github.com/docker/docker. You can look at the source code yourself. Most people, however, in this room, who is not running Windows and not running Linux and not running Mac? You. You already are running Docker, so I don't need to talk to you. Everyone else in this room, you can get Docker for Mac and Windows. It went GA a week and a half ago, and it is awesome.
What's
you want
GA?
General availability.
Oh.
It's also known as Docker 1.12 or higher. This is the version you want to get. It's called Docker for Mac or Docker for Windows. It is awesome. If you do have an older system, if you're running something, an older Mac or a non-Windows 10 Pro system, you might have to get an older version of the Docker toolkit called Docker Toolbox. Now this includes VirtualBox. Oh, wait a minute, Tess. You just spent like 2 minutes ranting and raving like an idiot about why you hate VMs, and now you're saying Docker uses a VM. Okay, I'm leaving. Nope, sorry, Tess, you're full of garbage. I'm leaving. Okay, let me get a step back for a second. Docker and Linux depend on each other. Every time you run an application in Docker, it's running on Linux. Linux provides the sandboxing and runtime necessary to run the applications. Docker is actually an orchestration and infrastructure solution. So it ties all of that stuff together for you. So Linux is doing really the heavy lifting, and Docker is making everything a lot easier for you to work with. So if you have your containers, your Apache, your MySQL, your PHP, these are your containers running in Docker on your system. Those are going to be running on top of the Linux kernel because they're Linux applications. The Docker engine is going to mediate those resources between the Linux kernel and the containers, making sure everybody has just the resources necessary. On your system and also bridging to the Linux kernel is also the Docker utilities. Now, if you're running this on Mac and Windows, you can immediately see the problem. You have a Linux kernel, and then you have Mac OS or Windows on your system. They're both doing an I am Spartacus thing. No, I'm DOS. No, I'm DOS. And then they have this little slap fight on your system. So what you have to do is you have to separate the two squabbling toddlers and put a fence around them. In this case, you're going to put one of them in a hypervisor. So we're going to put Docker and the Linux kernel inside of a hypervisor.
Okay, wait, before you go. What purpose is the container?
The containers are these little applications way at the top.
So there's more than one container? Or
You can run more than one container in one hypervisor on your entire system. This is one of the advantages of Docker over Vagrant, where you can run multiple applications that all think they're independent servers on one hypervised VM. Okay. Docker's hypervisor in 1.12 is embedded. It's an open source product called HyperKit on Mac OS or Hyper-V on Windows. On an earlier version, it uses a VirtualBox VM. If you're on Linux, like me and Mr. David Sopak over there, you don't need a VM because it's just going to use your host's Linux kernel. You don't need a special installer, just use your distribution's package manager to install. All right, that's all the getting stuff. Now, how do we actually start doing this? Where do I get these fancy containers? Well, Docker is actually a lot like Vagrant. You rarely build containers yourself. There's actually an online repository called Docker Hub, which provides tons and tons of ready-to-use containers at hub.docker.com. And anyone can upload this. So let's say that I come up with a container. My hair is not nearly as awesome as that guy's. I'm going to have the container source code, and I'm going to upload that to Docker Hub. Docker Hub will take that source code, build an actual working, running container, and then it's going to save that as an archive, and then I can download it later to my system using my terminal, and it gets copied and cached to my local system so I don't have to download it again. All the build happens out on Hub, so I don't even have to run the building myself. There's tons of official creators, which are containers created by a lot of project maintainers like PHP, Apache, MySQL, and also several different Linux distributions. So these official containers are going to be your go-to source because if you remember, anyone, including weird personnel like me, could actually upload containers to Docker Hub. There is an official Drupal container as well on Docker Hub. And it's really great for demos. Don't ever, ever, ever use this to do any actual development. It is explicitly created for demonstrations. Don't use it to do real development. You will hate me, you, Docker, and everything else within a few minutes of trying to get it to work. All right, how do we download one of these containers? We go to Hub, we search around, we find a container we want. How do we get it onto our system? You open your command line and you issue a Docker pull. Oh, that looks a bit like Git. Oh, that's interesting. So you do a Docker pull, you specify the name of the container called an image name on Hub, and it downloads it to your system. So let's say we want to start with Debian Linux. Debian is often used as Linux web servers for a lot of Drupal and open source projects. So it's a really good quote-unquote base image to start with. So we'll do a Docker pull for Debian, and it will download it to our system. Now, one thing you will start to notice is that on Docker Hub, there's container names actually have two parts. There's an image name, and then there's this other part that sometimes shows up afterwards called a tag. Now, these tags allow us to create multiple versions of the same container, like PHP 5 versus PHP 7, or different variants of the container, like a standalone PHP CLI or PHP running in Apache. So it's different for every individual project, so you want to look up the documentation on Docker Hub to figure out what that is. Tags are also optional. You don't actually have to specify one. It defaults to a tag called latest. And a lot of containers will just need to use latest as your regular tag. Okay? All right, so we've downloaded Debian. How do we get it to work? To run a container, you do docker run and you specify the image name. So this is our command to run Debian Linux on Docker. Docker, you can do this right now if you want. You might kill the Wi-Fi. Docker run -i-t Debian blah 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 blah. What is all this stuff? Okay, so -i means run interactively. I want to actually interact with this container once it starts up. Emulate a terminal so that I get a command prompt and it behaves like I expect if I'm SSHing or telnetting into a system. We specify the image name to start, which is just Debian, and then the command to run inside the container, which is just a standard bash shell. Okay, it looks like this. And you'll notice we get into our container and we get an actual prompt, and we can find out that this is just running Linux. I did this snapshot from macOS. So I'm definitely not macOS anymore. As far as this container thinks, it's in Linuxville. After that, you can just use exit to quit like you would out of SSH or telnet. Just at any time, just do an exit. Okay? You can also run containers in the background. You don't have to run them interactively. So in that case, you want to use the -D switch. That -D means detach, so detach from your terminal environment. And don't worry about this huge long line of garbage here. This is a hack that basically means do nothing forever. I'll get back to why you need to do that later. And then you get this really long, ridiculous string of characters that starts with B4D. I don't know who D is, and I don't know why I want to be that. This is called a container ID. It's a unique identifier for that container instance on your system. It is unique across the entire world. And well, the thing is, don't need to use all of those characters. You only need to know the first few, which are unique on your system. In the last 2 years I've been using Docker, I've only had a collision once. And I had to use 4 characters. All right, you started up a container in the background. How do you list it? How do you know that it's still there? There's a docker ps command. It's like the Unix process command, like listing processes. If you want to actually enter into a detached container that's already running, you can use the docker exec command. So you specify docker exec, the container ID, and then the command to run inside the container. So we actually use that to enter into our B4D container, and we get a prompt. Cool. And then again, just use exit to quit. How do you stop a container that's running in the background, or really any container by ID? You can use a docker kill command and specify the container ID. Cool. Yes?
Is kill graceful, or is it just like I'm going to terminate the process?
It terminates it gracefully, in my opinion.
It sends a kill, though you can stop if you want to terminate it gracefully.
Really?
Yeah.
I didn't know that.
It doesn't matter most of the time.
Yeah, it doesn't. Docker doesn't really
If you want
care.
it to clean up, send a stop.
Okay.
Push it stop.
Good to know. I didn't know that. All right, so how do we build a web stack? Running Debian by itself is boring, and we don't want to build everything manually. That's the old way. We want this automated. So, first of all, we have to know that a container is just a process. It's not exactly true, but it's pretty close. Now, when we think about a LAMP stack, there are multiple processes. One process should, by best practice, mean one container. This is why you don't want to use the official Drupal container, by the way. One process, one container. So we have an Apache server that has PHP on it, and we have a database server. That's 2 processes, so we need 2 containers. Okay? How do we get 2 containers? We're going to use something called Docker Compose. It's built in with Docker now. A few years ago it was optional, but it is the part of Docker that made me love Docker. It makes things so easy. It lets you manage several containers at once in what I call a container set, and it lets you do that with just one file. That file is called docker-compose.yaml. It is descriptive, not imperative, and you want to save it in the root of your project directory. So let's define a basic composer file. This is it. This is everything we need. We start off with version 2. This is actually the compose file version, not your version, not the Docker version, not even Docker Compose's version, but the Docker Compose file version. So it has to be version 2. And then we specify the number of containers or services we want to define. We create one called web, and we create one called DB. The web container is going to be pulling the PHP image from Docker Hub using the Apache tag, so an Apache web server that has PHP on it. And for the database, we're just going to pull the MariaDB container from Docker Hub, which is an open source variant of MySQL. All right, we made our file, we saved it to the root of our project directory. Let's start it up. How do we start it? We do a Docker Compose up. And just like we did that Docker run before, we're going to run it in the background with -D. Remember that the docker compose.yaml file has to be in the same directory that you execute this command from. Otherwise, compose doesn't know where to find the file. So we start it up, we get our containers, it all starts up and all starts working, and we want to list just what's running in our container set. So we do a docker compose ps, and we actually get a list of all the containers running in just our container set, as opposed to system 1. You'll notice something a little weird, though. What's with that name? I mean, it's an example, sure, but it's kind of weird. Where did it come from? Well, Compose actually does something really nice with container names. It auto-generates them for you. So it takes the parent directory name of wherever the Docker Compose file is, takes the name of the service in the Compose file, and a unique index, and that's what it means the container. So this particular time, I actually put this in a directory called home/test/project/ride the whale. I put my root of my Compose file in the root of that directory, so that's where it got that particular bit of the container from that parent directory. Cool. All right, well, we need to map ports too, because we have an Apache container, we want to be able to access it from our host system. So we have to basically tell Docker, on my system, take this port and put it on this port in this particular container. And that's needed to access that container from your host system. And it takes this form, the port on the host, : port in the container. Make sure to put it between double quotes, because otherwise YAML will freak out. Looks like this. So we just added 2 lines to our Compose file, a ports statement under our web container and the port mapping. Cool. Now we need to update our container set, because we already have it running. So how do we get it to reflect these new changes? Well, we do a Docker Compose kill, and then we do another update. And then it will read the file, remap the port, and everything's cool. And then we can finally open a web browser, and we get a 403 error. Wait, that's good. We don't have Apache on our host system. So the fact that we got a 403 means that Apache is working. There's just nothing there to serve. So now we need to get our files in the container. How do we get the files in the container? Docker Compose provides something called volumes. It can do 2 things. It can create a persistent directory inside of a container, but most often what you use it for is to mount a directory or file on your host system in the container. To make a volume, what you want to do is in the volume section, you want to specify the path on the host and the path in the container. It's kind of like the ports mapping statement in the same way. So we add, so remember this is what our project looks like. We have a doc root directory with an HTML file. In our Compose file, we're going to add these 2 lines, volumes, and we're going to add our volume statement relative to the docker-compose YAML file to var www/html inside of the container.
And that one doesn't need double quotes?
That one does not need double quotes, because it's something with how YAML interprets numbers. Because YAML sometimes will interpret, I think, 80 as a hexadecimal number, and it screws things up. You might have noticed that we use a combination of relative and absolute paths. This is actually not official, but this is considered a good best practice. On your host system, you want to use relative paths to the Compose file, and then when you're specifying the path inside the container, use an absolute path. That will give you the most predictable results. Okay, so we kill our container set, we up it, we refresh it, and behold, we have our amazing page and it's in a Docker container and stuff. Cool. All right, what about that database? Well, we need to get some information into that database first. We need to get the database name, our credentials. We need to get configuration into our database. So what do? How do we pass configuration to a container? There's a number of different ways. We can bake it into the container so that the container always has the same database, always has the same login, but that's really inflexible, and we don't want to do that. We could mount a configuration file with a volume, but that's complicated and can be subject to weird errors. We don't want that either. Most containers just specify environment variables. So you set an environment variable, the container picks that environment variable up, and then we'll start using it for you. So how do you set environment variables in a Compose file? You specify an environment section and then the environment variable key and value. What variables do you need to use? It really depends on the container. So go to the containers documentation on Docker Hub. They'll list out what variables you need to use and just use those in your file. So we did the research for MySQL. And we actually found out that we have these few variables that we need to define. So we have MySQL root password, the database name to create, the user, and the password. And we're specifying some really, really bad user-using passwords that make it really hard to squeeze things in slides. All right, wait. Let's go back to that file. There's no port in our database. How does if both the DB and the web container are separate servers for all intents and purposes, how do they talk to each other? How do they know how to communicate? Why is there no port statement? Well, in Docker and Docker Compose, all containers in the same set get their own automatically created private network created on your system that connects all the containers to each other. Furthermore, most containers you find on Docker Hub are already pre-configured with the right ports on them, so they'll be able to communicate with each other easily. So you don't usually need to worry about that. Now, if you want to talk to the MySQL database on your host system, you'll want to go back to your Compose file and add a port mapping to your host system so that you can access the MySQL database. But you don't need to do that between containers. Okay, cool. So we actually kill and re-up our container set, and we can actually use a MySQL client, and we can specify our host name as localhost, because a container is virtually on your same system. And then we specify the port, and we're inside of our database. Boom, just like that. We don't need to install MySQL. Now for Drupal. We have everything else set up. Let's go. Okay, first of all, prep the files. Download all your Drupal core and your modules to the volume-mounted directory. Create and set permissions for your files directory. Create your services.yaml for Drupal 8 and your settings.php as you normally would. Okay, and then we finally go to localhost. We run up our browser and boom, we have an install. Finally, we got that far. And then you decide to keep going, and you go to the requirements page, and you find a big red X. Maybe we could customize that container. We're missing some requirements. Maybe we could add them to the container. How do we customize containers? Earlier I talked about container source code and what that is uploaded to Docker Hub. That's called a Docker file. Docker files are always named Docker file. And unlike the Compose file, they're imperative, not descriptive. Do this, then this, then this. So first of all, you want to create some directories for your containers. This isn't actually standard. This isn't even considered a best practice, but it's really common, and it's still just a suggestion. I like creating a Docker directory because I'm the crazy Docker person, and not everyone else wants to see a Docker directory in their project. And after that, I create a directory for each container in my container set. In this case, I put the Docker file under the web subdirectory under the Docker directory. Okay, now I'm going to edit that Docker file, and I specify 2 lines. The maintainer line is pretty obvious. That's going to be the email address of the person who maintains this Docker file. But the other one's kind of weird. That's an image name from Docker Hub. Why do I need to specify that? Well, it turns out that containers are kind of like turtles all the way down. Every container is based on another container. So you might have a container which runs Drupal. That container is based on another container that runs PHP. That container is based on another container that runs Debian Linux. And on until you get to the parent of all containers, the Scratch container. The Scratch container is the starting point for all containers in Docker, and it's just an empty tar.gz file. You might have heard the phrase base image before. That's technically defined as whatever base Linux install you're going to be using, which is Debian, CentOS, Arch, or so on. But the term's a little slippery, and a lot of people say it's whatever image you start with in your Docker file. Also, there's a weird thing about Docker files. There's no install directive. This is kind of like that movie 300. This is Linux! Everything is going to be whatever that container decides to do. So instead, we have to know what that kind of Linux is going to use. So if we're using Debian, we use apt-get. If you're using CentOS, it's going to be Yum, and other containers will sometimes provide special installation scripts. So you need to do a little bit of experimenting, a little bit of research, and a little bit of hacking. Since we're going to be using Debian, the good news is that pretty much any server installation tutorial that you find online is going to work in Docker, because it's just Linux, nothing special. So to run these install commands, there's a run directory, and it's not just for installing software, it runs literally any command in the container. So we did some research and we built up our container, our Docker file, and we found out we needed this. So we start with the PHP Apache image, then we're going to update the software, and then we're going to install the following packages. And this is a whole bunch of stuff that unsurprisingly, GD requires in order to function. The PHP container also provides a special installation script to handle PHP extensions. So here's the extensions that we need in order to run Drupal 8. So those are everything you need. Hint, you don't need to you can create this Docker file, go to Docker Hub, search for socketwrench/Drupals-base. I did the work for you. All right, how do we use our Docker file in Compose? Well, there's a build statement that takes a path to the Docker file. Use it instead of image. So in our Compose file, everything looks exactly the same as before, right? Except here. One line. We just changed that one line. It says build, go to the Docker directory, which is local to it, which is in the same root directory as our project, which is where the Compose file is, to web, where the Docker file lives. We don't need to specify the name Docker file. So we only needed to change one line, just one line, and suddenly it works. Well, yeah, because we started with the PHP Apache container in our container set. And our Docker file starts with the PHP Apache container in the Docker file. So it's like we're extending that. It's almost like object-oriented programming. And where we're extending a class, in this case, we're extending a server. Now think about that concept for a minute. That's really powerful. All right, now we have to add another step to building our container set. We can't just up it, we also have to run a build. And the build is going to go and look at those Docker files and build them. You can specify the service name of the container that uses the Docker file. If you don't, Docker will just look at any service in your Compose file that uses the build statement, and it will build it for you. And you must do this before up, otherwise Docker will just re-res the old image. Okay, yes?
Does it run arbitrarily? Vagrant, for example, will pay attention and upon provisions, for example, say I've done this before, and you force it and you have it redo the steps. Does it do it arbitrarily, or does it keep track of it?
It keeps track of everything. Every step in a Docker file is like a git commit. So it actually will create a new image on top of it with every step that it executes in the Docker file. And when it's finished, it will actually create a new container on top of that old image.
Oh, there really are a lot of turtles.
Yes, there are a lot of turtles. All right, Drush. How do we add Drush? Guess what? There's a container for that. On Docker Hub, it's just going to be Drush/Drush. But wait a minute. We can get to the MySQL database because they're all in the same private network. But the files are only on the web container. And this is another container, which is its own server. How do we get the files onto that? Well, we can reuse the volume. We could copy and paste the volume section from our web container into the Drush container. But if we change one, it becomes a big mess, and we have to change it in multiple places, and we don't want that. We could use something called named volumes in Compose 2, but that's complicated. Most people are going to use volumes from. So we actually go ahead and into our Compose file, and we add a new service, a new container, our Drush container, which is using Drush/Drush, and we'll see that we have a volumes from statement. And we just specify the name of another service, in this case, the web container, which basically tells Docker, when you start the Drush container, use all of the volumes from the web container. no matter how they're defined, and mount them all in the same places. Okay? We re-up our container set, and we do a Docker compose PS to see what our container sets are doing, and you'll notice something weird. Wait, the Drush container is not running. Why did the Drush container stop when everything else is running? Well, there are actually task-specific containers in Docker. Our MySQL container and our Apache container are background containers. They run all the time. We expect them to stay up because they're supposed to be running. But the Drush container is task-specific. We don't want it to run all the time. We only want it to run when we use it. So what happens in that container is it's configured to execute a command and then immediately quit. And it must be run interactively. So to run the Drush command, what we're going to do is a Docker compose run, Drush, and then we specify the Drush command. This is our container name, and this is the command. And this actually does create a new container instance each time, but it's really small. It's not going to completely eat up your hard drive. Remember that a container is just a process, and it will stay up as long as its process does. So once that Drush container is finished doing its work, it stops. All right, we can install Drupal inside of our Dockerized Drush container that goes to our web in our database container with this command. We just do a Docker compose run, Drush SI. We pass a whole bunch of arguments in order to specify what the host name of the website is, which is the same to the container's perspective as the service name. And then we mount our root volume, our root directory of our Drupal installation, and our long MySQL database string, which the server is, again, the same as the service name. And then we install Drupal. Ta-da! We have Drupal installed inside of Docker. What if you have an existing site? First of all, I'm going to say something that's going to be controversial. Avoid database dumps if you can, please. Please don't use them if you can at all get away with it. Because DB dumps are like Tribbles. Have you ever heard of a Tribble before? Who hasn't heard of a Tribble? Okay, you're the only 3 people in the world who's never seen that episode of the original series of Star Trek. Your assignment tonight is to go watch it on Netflix. That's fine, okay. I don't watch it anyways, I want the whale back.
The episode's name is The Trouble
With Tribbles, yes. There's also a DS9 episode, but I'll get into that another time. The thing with Tribbles is that it's this little tiny purring fur ball, but if you feed it, it will reproduce very quickly. And it quickly becomes a huge problem. It can overwhelm an entire ecology. And that's what a DB dump really is. They don't seem like, oh, I'll just use a DB dump. It's only 14 megabytes. It's no big deal. 3 months later, it's only 4.5 gigabytes. It's no big deal. That's what a DB dump is. It's a Tribble. It's going to eat you alive and make everything slow. So if you can, try to avoid that. Instead, work with your client to do a card sort on their existing content, and then try to come up with representative content that matches all the features that they expect to have on their site. Then put that content into code. With Drupal 7, you can do this with UUID features. Drupal 8, it's still a little bit undefined, but it's easy to actually do that with raw code. Yes?
Yeah, so say you're working on a site like Drupal.org that has 1.5 million nodes or whatever it has. Like, I'm totally on board with not having a database dump, but there are certain considerations you need to give when you're developing new functionality on top of data that large. And I guess my concern with this approach is that you wouldn't necessarily hit scalability issues in your development environment unless you had a representative sample of the type of size of data they want.
All right, so you have the database dump. You can't avoid it no matter what. Sorry. Okay. You can use a client on your host system to load it. So you can actually do that. Just like we did before when we used MySQL to access the database from our host system, it's the same idea. You can just load it into the database container using the same methodology. And it's best for small databases, but the thing is if you have really large databases, it looks like this obviously. You can actually do a Docker compose exec, you can run MySQL, and then you can pass in the path for your database stuff. Okay? But if you have a huge database, you might have a potential problem. There are ways of doing it. You can actually increase your max allowed packet inside of the database container. It's a little tricky, but you can do it. But another better way is to mount the database, is to import the database from inside the container by mounting a volume that contains either the dump file or existing database files. There are lots of techniques to do this. This is kind of advanced stuff, so I don't really want to give a suggestion here. Okay, how do you clean up? Yeah.
The database stuff, have you used like a Drush container that's like specific to copying, let's say, the dead database down to your local?
I wouldn't use a Drush container for that. What I would usually do is create a generic CLI container. I don't actually talk about that in this talk because it's it takes a while to set up, and I've never been able to squeeze it down to more than 25 minutes to describe it. But that's what I would do. I'd create a standalone CLI container that contains all of my Drush utilities that stays up running in the background, and then I would write scripts that would actually automate the importing of that database.
That makes sense.
Okay, how do you clean up? You're done with the project, you want to get rid of stuff. Well, if you want to just delete your container set, you just do a docker compose kill like we did before, and then a docker compose rm or remove. And that will delete your container set. But a few months later, you might find out, wait, I deleted all these containers, but my disk is still full? What's going on? First of all those volumes that you mounted inside of your containers aren't deleted by default in Docker. They're going to keep them, unless if you explicitly say, yes, go ahead and delete the volume. So to do that, you want to specify -v whenever you delete a container set. That will delete the volumes as well as the container. All right, is there anything else? Well, there's also images. I mentioned base images and also downloading images from Docker Hub. An image is basically a snapshot of a container. It's whatever you get whenever you do a Docker build with a Docker file, or also if you download an image from Docker Hub. And these stay in the background in your system. You can actually list all the images using the Docker images command, and you can see how much space they take up too. Which actually looks a lot bigger than you think, but it's actually still smaller than several VMs. How do you delete images? You actually can do a Docker RMI. Docker RMI actually takes the image ID, which is kind of like a container ID, follows the same rules. You can use the first few unique characters in order to delete a specific container. If you want to delete them all, you can do a Docker images -q in a subshell. This deletes all of the images off of your system. What if you need to nuke the whole damn thing from orbit? Because it's the only way to be sure. This will actually delete practically everything on your system. You can kill all the containers, you remove all the containers and their volumes, and then you remove all your images. Sometimes you have to do this if you're low on disk space or Docker just plainly gets really freaking confused, because that happens. Do not hold on to your containers for dear life. Throw them away as soon as they become a problem. That is what Docker expects you to do. It expects you to throw containers away as soon as you're done with them or you don't need them. You can always rebuild it. If you're on Docker for Mac or Docker for Windows, there's an easier way than running this really long command. You can open the Docker application, go to the preferences, go under uninstall/reset, and hit the reset to factory defaults button right next to the really, really unsettled picture of the web. This will take a few minutes. It will delete everything off of your system. When I did this recently, it freed 40 gigabytes. I really shouldn't have tried to get that 5 gigabyte DB into a 4 gigabyte RAM MacBook Air. That was a very long day. Where to go from here? Well, you might want to create a better CLI container. How do you do that? Well, you can use something that Linux provides called Supervisor to create an always running container. Then you can install Drush, Drupal console, Sass, Grunt, any other tools that you actually need in order to run your particular web stack, so that none of your team members ever have to install it on their host system, and they're always configured correctly with the right settings. And yes?
Do you create one container for all those commands, or do you create individual containers for each?
I tend to create one CLI container that's literally called CLI that runs in the background and has all of this in it. It tends to be a bit more of a bespoke operation, so I tend to build that with a Docker file, but I have built a generic one on Docker Hub called Drupal-CLI, which has, I think, Drupal console, Composer, and Drush. It doesn't have Sass or Compass or Grunt or Gulp or anything else, but you can, obviously, you could just extend that with your own Docker file and build whatever the heck you want. And there are other containers out there which do all of that for you too. So you can just probably find them. Also, you can use Docker Compose exec instead of Docker Compose run to get that command environment to run a bit faster, because Docker doesn't need to initialize a new container. You can also read the documentation on docs.docker.com. I also created a blog post series called Docker from Scratch on devnet.com, which takes a more build up from the ground up approach, starting with Docker files, building a very complicated Drupal web stack from scratch, so that we give you all the details, and it's a really good read. Lots of people really like that series, so give that a read. Also, you might want to say, Tess, that's all boring. I just need to get work done. How do I get work done? Well, you could use pre-made containers. There are lots of options to choose from. If you're a Drupal 8 module developer, you might want to use my personal project, which is called Dropwell. It's a drop-in Drupal 8 development environment. So you take your module repository, you copy one file in one directory, and then when you start that up, it will pull and install Drupal development dev automatically for you. You don't have to do anything else. It will mount your modules directory, it will enable your module with all its dependencies, and you can just go and rock. You can get Dropwell on GitHub at socketwedge/Dropwell. There's a newcomer as well that was just announced a week ago called Docker for Drupal. It's a bit more of an a la carte solution for building Drupal environments. It provides several different recipes and containers on Docker Hub. It's fully featured. You've got Redis, Memcache, Solr, everything you need to run a high-scale Drupal environment. You can find that at dockerfordrupal.org. And sometimes you have to build your own. There's nothing wrong with that. If you make your own container set per project, that's fine. It lives in your repo with your project. That's good, because anytime your project requirements change, it's in the repo. Just change it. You're done. It's cool. Also, you might want to contribute your containers back to Hub. You created a really awesome Redis container or a really nifty CLI container. You want to share that with everyone. You can just upload it to Hub. It's free. Anyone can do it. Plus, when you do that, Docker Hub does the build for you, so you don't have to waste 15 minutes while it installs everything. It will do all the builds, and all you have to do is download the images from Docker Hub. It installs in a few seconds, and you're ready to go. I want to take a moment for some special thanks today for the DrupalCorn team, which provided me some financial assistance so I could actually be here today for 10/7 for some contracting work that I'm currently doing. Mark Drummond and Paul Mitchum for their wonderful encouragement with this series and their help and being my guinea pigs with this. And also lots and lots of other people who have helped me get to this point. Thank you. You can read the blog post series on Denanet, and you can find this presentation on github.io. Yay!